Good evening. Sorry for the delayed start. We had some technical difficulties. We have overcome them right now. Good evening. I would like to start with a brief introduction to the Science Forum. We have an unusual situation where the speaker says he'll introduce himself because he's had too many people misintroduce him. So the Varahamihira Science Forum was started a couple of years back. We are right now in our third year. We started it to inform the general public about various topics of science, give it a popular approach, rather than just the technical conferences that happen in technical institutions, whether it be the IITs, the medical colleges, the mathematical institutions, seminar, professional organizations, and so on. We wanted to have a forum where the general public can access science in a not too technical fashion. So we invite both amateurs and professionals to present lectures on various topics. All our lectures are on YouTube. We have a channel, Varahamihira Science Forum. We have an active Facebook group. We have an active WhatsApp forum. You can join that anytime you want. So this is roughly the third year of our program. We started in August 2017. We have completed over 27 or he served in the Institute of Mathematics Sciences, and one of our fine well-wishers, N. Balasubramaniam, the gentleman in the picture who's standing, a very good well-wisher of ours, who's been with Tamil Heritage Trust and Varahamihira Science Forum since day one, a very good friend of us. He passed away a few days back, about 10 days back. He is a enthusiast in several, he's a polymath. He was a professional mathematician. He was a cryptographer. He worked for the Department of Defense as the director of the Joint Cipher Bureau. We don't know much about his professional activities. He kept a lot of them secret, naturally. But he loved to talk about mathematics, loved to talk about cryptography. He was very passionate about Sanskrit as a language, Tamil as a language. He actually knew smatterings of German, Italian, Latin. He'd quote, he has read Boccaccio's Decameron in Latin and its translation, Arthur Ryder's translation of the Panchatantra, an enormous amount of reading. In Delhi, he was known as Bharati Balu because of his enormous passion for the works of Subramanya Bharatiyar. In fact, some of the exhibits that you see in the Bharati Illam are from his collection. The one in Trivilikeni is from his collection. He was a very passionate mathematician. He was, very enthusiastic in poetry. He's a translator. He's written short stories. Ashok Mitran selected one of his short stories, Maranattu Magadam, as the finest short story to be published in Kanayari several years back. And so a man of great accomplishment, and he passed away a couple of weeks back. And as a tribute, I would like you to observe 30 minutes of silence. If I could request you to stand up for about 30 seconds. Thank you. Tamil Heritage Trust will honor Balu sir. We'll have a memorial program for him either in January or February when we can arrange it. So without much further ado, I'd like to thank Dr. Srinivasa Rao, who was a professor at Math Sciences for several years. He has kindly offered to speak about the life and works of C.V. Raman. C.V. Raman, we all know, one of the most prolific scientists. He is going to give a talk about it and then show us a documentary. So I invite Dr. Srinivasa Rao to address the gathering.
Got it.
including the document.
Got it. Good afternoon to all of you. Good afternoon to all of you. Mike? Huh? No. Hello? 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 இங்கே பவர் இருக்கு. Hello? 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 So, good afternoon. As was mentioned, I've been with the Institute of Mathematical Sciences from the year 1964 after I finished my Presidency College studies in Presidency College with a master's degree. And this is one common point between me and the hero of the day, Sir C.V. Raman, Chandrasekhar, and I. We all passed out of Presidency College with honors. So my name can be found on the same board along with the names of these two people. So I think I showed the same promise when I left, but I don't know where I have ended. But where they have ended, you all know. So today we are going to talk about the life and work of Sir C.V. Raman. He is a person who lived for 80 years, so 82 years. So naturally he was prolific. And he's a person who is incomparable in the sense he had a zest for doing physics, and science was his greatest passion. It was a passion for him. Even during the last 1 week before he passed away, he, it seems, called somebody and said, "What did you do with the work which I wanted to do?" And he was taking the person to task for not doing it right and so on. So even at the very outset, since I do not have it on the slide, let me tell you that if you are interested in reading about Venkataraman, there are two sources. The one which I would recommend for people who are interested only about his life and not about the work is one written by a person called Pisharoti, P-I-S-H-R-O-T-Y, Pisharoti, P-I-S-H-A-R-O-T-Y, Pisharoti. It came in a series of books which I do not bring the copy of the book with me, therefore I do not remember now which series it is. It's a small book. It's a booklet, I would say. I mean, something about 60 to 80 to 100 pages or so in a small size. So that gives information about the life of Raman and also all that he did during the before and after the discovery of the Raman effect. So that's a very nice book for people who want an introduction about Raman. But for those who want to know exactly what he did, and if you are deeply interested after what I am going to tell you today, if you want to know more about the contents of what I am presenting to you here, you have to read the book by G. Venkataraman. Dr. G. Venkataraman was the person who was with BRC first, and then he came along with the group of people who set up the IGCAR in Kalpakkam. So he's an atomic energy person, and he was the head of one of the divisions of IGCAR. I think he was the head of the research group or something like that. He came in a very good position here. And G. Venkataraman took it upon himself to write about the life of Raman in a massive volume, which is entitled Journey into Light. So that's the title of the book, Journey into Light by G. Venkataraman. Is the Bible for those who want to know the technical details about the work of Raman. So with these words of introduction and also telling you that I have my time cut out, apparently Gopu tells me that this place has to be available till about 5:45 for me. So I have 1 hour's time, and I have a documentary on Raman, since I thought for those who would like to see him on the screen, of course somebody acts the role of Raman in some parts, and he himself appears in some parts. this is something which should be more interesting than listening to. I mean, a picture tells you 1,000 words, equivalent to 1,000 words. So I put in a lot of effort to gather all this information and show it to you. These are taken mostly from the book of Journey into Light, partly from Journey into Light, partly from Pisharuti's book, and also partly from the web, because several of the pictures I was able to get from the web also. So with this as introduction, let me quickly run through. You have a pointer or something, Gopu? No? No? Laser, I did not bring one. Laser ka? Left, right? So Chandrasekhar Venkatraman's ancestors were agricultural landowners.
You have to speak in the mic.
I have to speak. Oh, because of the connection. Okay, I think I have to be glued here because they want things to be broadcast. So Chandrasekhar Venkatraman's ancestors were agricultural landowners. They owned land in Tanjavur district between the two towns called Porasakudi and Mangudi in Tamil Nadu. The first son of the parents of Raman died in his infancy. So Raman happens to be the second son to his parents, and he was born on 7th of November. So the date of birth of Raman is 7th of November, the date on which 1888, and he died on 21st November 1970. So both the date of birth and date of death are in the same month, and I think that's probably the reason why Gopu thought that this is the month when we should talk about Raman. So Raman, the second son to his parents, was born on 7th November. It was a Wednesday at his maternal grandfather Saptarshi Shastri's house in Thiruvannaikkaval. Legend has it that there was a Anai is the word which is involved, which makes the sense. Thiruvannaikkaval stands for an elephant which prayed to Lord Shiva in that place. That's the Sthala Puranam of the place. The renowned Sanskrit scholar Shastri walked all the way to Bengal, 2,000 kilometers away by walk, to learn Navya Nyaya, which is what is called modern logic. Raman was one of 8 children. The parents of Raman had 5 sons and 3 daughters. And at age 4, Raman's father became a lecturer in Mrs. A.V. Narasimha Rao College in Vizag, Visakhapatnam. That was called as Mrs. A.V. Rao. Raman read the books of his father, who had intentions of doing a master's degree in physics, but he did not. He discontinued. And so he had the books of his father on physics and mathematics to start with. And Raman also read books which he borrowed from his father's college library. So Raman did his schooling at St. Aloysius Anglo-Indian Higher Secondary School at Vizag in AP, and he stood first in the matriculation examination and joined AVN College. So this is the Mrs. AVN College in Vizag for his intermediate. Raman, though physically weak, was excellent in his studies, exhibiting an unusual talent by winning many prizes for proficiency. In the year 1903, when he was hardly 14 years old, he came to Madras to do his bachelor's degree in arts. It was in those days BA for mathematics and physics also. BA degree in physics at the Presidency College. And he wrote later, indeed in the first English class I attended, Professor E.H. Eliot, addressing me, asked if I really belonged to this junior BA class. And I had to answer him in the affirmative. He then proceeded to inquire how old I was. So he was puny. Raman completed his schooling in the year 1904. During vacations, Raman demonstrated experiments to his siblings. Coincidentally, Ramanujan also completed his schooling by about the same time. Raman and Ramanujan are the 2 Himalayan peaks who brought fame, name and fame to this country, and both of them belong to Tamil Nadu. So as I said, Raman won prizes for proficiency in physics and English, and accolades and certificates from his teachers. The teacher said, the best student I have had in 30 years, possessing great alertness of mind and a strong intellectual grasp, exhibited an unusual appreciation of English literature and a facility in idiomatic expression, a young man of independence and strength of character. There are many more, but this I thought it gives you an idea of what the teachers thought about him. his British lecturers wanted him to go to United Kingdom for his master's degree. They wanted him to go to England. Just as Ramanujan also was being sent to England. But the civil surgeon of Madras ruled this out because he was puny and he was not having good health. He ruled him out and said that you will not be able to withstand the temperatures and pressures which you have if you go to that country. And so he told Raman that his health was not robust to withstand the rigorous colder climates of England. Raman later said, I shall be ever grateful to this man. He was awarded the bachelor's degree in the year 1904 and the master's degree in the year 1907. So Raman was awarded a scholarship for his MA degree in physics at the Presidency College. About Professor Llewellyn Jones, Raman wrote later, he was the head of the department. Professor Jones, believing in letting those who are capable of looking after themselves to do so, with the result that during the 4 years I was in Presidency College, I enjoyed a measure of academic freedom which seems almost incredible. To mention only one detail, during the whole of my 2 years work for the MA degree, I remember attending only one lecture, and that was on Fabry-Perot by Professor Jones himself. Raman was given an unlimited access to the laboratories by Professor Jones to pursue his investigations in recognition of his outstanding potential and his spirit of inquiry, which drove him incessantly to do experiments throughout his life. In November 1906, 18-year-old Raman wrote his first academic paper, but one of his professors whom he approached did not even read the paper. Raman then had the courage to submit the paper directly to the journal. Raman graduated at the age of 19 with his MSc in physics with the highest distinction. He submitted his first 2 papers to the same journal called Philosophical Magazine. Undaunted, Raman directly, undaunted by the fact that the professor refused to even read the paper, Raman directly submitted the paper entitled Unsymmetrical. Oh, okay, I can do that. Okay, then I cannot show that there. Huh?
People read on this.
No, it doesn't work like that.
So I just asked him to speak because he's seeing the screen. You can follow it on the screen rather than the pointer because the mic is not picking up well. Set up a power mic for the next time.
So undaunted, Raman directly submitted the paper entitled Unsymmetrical Diffraction Bands Due to Rectangular Aperture to the Philosophical Magazine in November of 1906. It was accepted for publication. The first paper in it was perhaps the first paper ever from Presidency College, and possibly it was that magazine, Philosophical Magazine, was not available anywhere except in the Connemara Library. It was the first paper to come out of Presidency College, Madras. Following the publication of his second paper also in the Philosophical Magazine, Raman received a letter from Lord Rayleigh. Lord Rayleigh was already a very famous established physicist, who, unaware of Raman being a teenage student, sent his letter addressed to Professor Raman. So just to give you an idea of the kind of apparatus which Raman used, because it was India is a country where there was not much of equipment, and but he made use of whatever was available. So this is a spectrometer, college spectrometer, and an ordinary prism, and Raman's simple apparatus for demonstrating the diffraction from a slit. This is A. This is a slit here, and there is the screen. Illustration to show how the interference is due to neighboring waves. These are waves, and there is superposition of waves which is responsible for the pattern which was being seen. A schematic arrangement, A is a schematic arrangement of Raman to study asymmetric diffraction using a spectrometer and a prism of face width 4.5 centimeters. The geometry of the experiment. This is the geometry. The light fell on this side. These are the beams of, and this is how the scattered light is coming from the base of the prism. Diffraction rays like AG lying beyond the limiting direction AE are not possible. AG, you can see this is AG, this is AE. So diffraction rays like AG lying beyond the limiting direction AE are not possible. The condition for interferences was very simple to derive this condition. So one can easily see this in BSc and MSc physics classes. A times cos theta minus cos phi is equal to plus or minus n lambda, where L is an integer. theta and phi have to be small angles. These are the angles theta and phi. The incident beam makes an angle theta, the outgoing beam makes an angle phi. Raman passed the MA examination, as I said, in the year 1907, January of 1907. The calendar year coincided with the academic year in those days. Going to England was ruled out due to his frail health. So Indian Civil Services examination was not suggested to him. Otherwise, everybody wanted to write the Civil Service examination, mainly because that was the best paying profession at that time. The next best for financial, for ICS or Indian Civil Services was Financial Civil Services, FCS. And C.S. Iyer, a brother of Raman, was already an officer in the financial services, civil services. The candidates were screened, and after the interview, Raman said, "I took one look at all the candidates who had assembled, and I knew I was going to stand first." I mean, his self-confidence was supreme, not only at that time, throughout his life, the amount of confidence which he had. And another factor to the confidence is also the ego which he had, played havoc in his life. Raman passed the FCS in 1907, and while waiting for the posting, his parents arranged his marriage with Lokasundari. This is the lady whom he married. Raman was 19 and Lokasundari was 14 years old. In fact, the story has it that on the first occasion when he saw her, she was playing Ramani Samanam Evaru. And in fact, I picked up that song, and if you might have noticed, that was being played. Ramani Samanam Evaru, coincidentally, it means who can be equal to you? Is there anyone who is equal to you? Rama, unakku yaravadu eedu irukangala. So Ramani Samanam Evaru is a Tyagaraja Kriti in the raga Karahara Priya. So I chose that, and it was being played to you in the initial stages. That is the reason for that. And that was being played by Lokasundari on the Veena. After the marriage, Raman got an extra allowance of 150 rupees, which was given to married officers. 150 rupees was a lot of money in those days. The Academy of Sciences resolved to award the Nobel Prize. And now I'm jumping. This, it will not be completely continuous. So you will have to accept that the work which Raman did is something which I will mention to you a little later. This slide should come a little later, but somehow I have not moved it. So the Academy of Sciences resolved to award the Nobel Prize for Physics for to Sir Chandrasekhara Venkata Raman, because by that time he was knighted, for his work on the scattering of light and for the discovery of the effect named after him. Raman saw Nehru's emphasis on useful applied research as misplaced. I mean, Nehru was always talking about science which you do should be useful. So Raman did not agree with that. Raman argued that fundamental science needed to be insulated not just from government, industrial and military pressures, but even from instructional pressures. So he did not want to receive instructions from even a person like the Prime Minister of India. When Nehru called for scientists to step out of their ivory towers, Raman said that the men in the ivory towers mattered the most. They were the salt of the earth to whom humanity owed existence and progress. Of course, you can see Nehru was somebody who went and saw the experiments which were going on and the people around him. So that should have come a little later. Sorry for the not moving the slide. Lokasundari was a remarkable lady and a complete match to Raman. When in later years he worked on flowers, he was working on all the things which were surrounding him. Flowers also, so flowers, fruits, the symmetry of those things, these things attracted him. So when he was working on flowers and started claiming that he deserved a second Nobel Prize, his wife is supposed to have said, "With one Nobel, you were intolerable. With two, you would be insufferable." This is a statement by Dr. Bhagavantam, a student of Professor Sir C.V. Raman, later years. Those who have known her had often said that her principal interest was to enable Professor Raman to carry on his scientific work with efficiency and in an uninterrupted manner. Seldom did she permit projection in the public of her own personality as distinct from that of her husband. This aspect of hers, besides being in line with the best of Indian traditions, was so noticeable on occasions that she drew the admiration of all concerned. The couple lived in Calcutta, Nagpur, Rangoon, and many other places, because as a financial services person, he was moved from place to place. So for about 10 years or so, he was with the finance department, and he spent his time in various places. And the wife was allowed to run the household. As Raman said, I know you would do an excellent job of it. Why should two people waste time on the same problem? In 1907, Raman was posted as Assistant Accountant General in Calcutta on a princely salary of rupees 400. He did not get lost in obscurity or oblivion, even though he had a very secure position. As a civil servant in the Indian Finance Department of Calcutta, Raman rose quickly to a very senior position. In the year 1867, Dr. Mahendralal Sarkar started a campaign to form a national association. This resulted in the founding of what he called as the Indian Association for the Cultivation of Science. When I was very young, I used to wonder, what are they cultivating? They are cultivating science. In the year 1876, with him as its first secretary. It was in hibernation until Raman accidentally entered into it one day. He was going in a bus and he saw this Indian Association for Cultivation of Science board, got down and just wanted to find out what was happening there. And he started, when he entered there, he found that it was in hibernation, there was no activity, nothing was going on. So he went and told Mahendralal Sarkar that, let me do something here, I want a lab. Can I use this lab? Can I come after my office hours and spend some time here? And Mahendralal Sarkar was more than delighted, because he had created an organization with the hope that somebody will cultivate science there, and nobody was coming to do anything there. When Raman volunteered to go and walk in and spend his time in the evenings, I mean, he has to a full-time job, and then in the evening after 5, he will have a cup of coffee or something, and then he will walk into the lab and would not leave the lab till 11 or 10:30 or 11 in the night. That's what most of his students said. So understand what the students should be feeling. You know, they would be feeling a lot of pressure from the professor being present all the time and demanding work from them. Raman's part-time research and his but still it was part-time research because he was doing a main job as a finance officer. Part-time research and his highly impressive popular lectures established him as a highly talented physicist, and many recognized his talents. In 1917, the University of Calcutta sought him and offered him the Pollitt Chair of Physics. Although this meant a substantial pay cut, the Pollitt Chair, it was a big name. Pollitt Professorship was a big name. But still, the financial amount which you would get from the professorship was lower than what he was getting as a finance officer. So though it meant a substantial pay cut, Raman's passion for full-time research made him accept the post at the age of 28. So Lord Rayleigh, we should know something about Lord Rayleigh, because now I'm going to give you a little bit of idea about what Raman did, research work which he did. Lord Rayleigh was a very famous person. He rose to become the president of the Royal Society, and he was a senior wrangler, graduated with mathematical tripos from Trinity College in Cambridge in 1865, and he was a Smith's Prize winner. In 1866 to 1871, he had a Trinity Fellowship. These are the kind of fellowships. Trinity Fellowship was offered also to Ramanujan. He became the third Baron Rayleigh, succeeding his father, who died in 1873. He was awarded also the Fellowship of the Royal Society in the year 1873. In 1877, he published his book, which was entitled The Theory of Sound. In 1896, he isolated the element argon. So Rayleigh is known mostly for his work, and particularly for the discovery of a new element and adding it to the periodic table at that time. And the element which he discovered is called argon, and it was therefore considered a very important contribution. Published many papers explaining scientific thought, and he wrote several papers. Insects and Color of Flowers was a book which he wrote. On the irregular flight of the tennis ball, the soaring of birds, the sailing of flights of the albatross, the problem of the whispering gallery. He was awarded the Copley, Royal and Rumford medals of the Royal Society. He was awarded the Nobel Prize in 1904 for his investigations of the most important gases and for the discovery of argon in connection with his studies. Rayleigh scattering involves, there is something called Rayleigh scattering. Rayleigh scattering involves the interaction of electromagnetic waves with the particles. That at that time, until the photon was invented and Einstein started talking about the photoelectric effect, people thought that light had only one nature, that was the wave nature. But it was during this time, transition period, that in the 1920s, that people realized that there was another aspect of it, that it had two phases. The light could either behave as a wave or it could behave as a particle. So Rayleigh scattering involves the interaction of electromagnetic waves with the particles, having the size smaller than the wavelength of the electromagnetic radiation used. Rayleigh scattering is elastic scattering. You should know that if you are playing a game of let us say billiards on the billiards table, the collision of a billiard ball with another billiard ball is an elastic collision. Whereas there could be inelastic collisions. The main difference between elastic and inelastic I have to emphasize, because it was here that Raman made the breakthrough. Raman was looking at inelastic scattering and not at elastic scattering. Elastic scattering means A plus B goes to A plus B. That's called elastic scattering. A and B are two particles. They come and hit each other. They go away as two other particles. Maybe they distribute some. There are conservation laws called conservation of momentum, conservation of energy, and so on. Laws of physics have to be followed. So that is called an elastic collision. But supposing two particles interact and three come out, or something happens by which they lose some energy. See, those are the kind of things which are very important for nuclear fission and things like this, where two particles interact, and what you would get would be a release of energy. So these are called exothermic, endothermic, and so on. So that's again detailed physics. So inelastic scattering means the two which are incident are not the same as the two which are going out. A could interact with B, and because of the interaction, it will go as, let us say, C plus D, to give you a very distinct idea of difference between the elastic and inelastic. If A plus B becomes A plus B, it is elastic. If A plus B becomes anything other than A plus B, like C plus D, then it is called inelastic scattering. A and B, A, B, C, D are particles. So Rayleigh explained that the sea's color is blue simply because it was a reflection of the blue color of the sky. In the summer of 1921, Raman was on a deck of a ship in the Mediterranean Sea en route to Oxford and began to doubt the explanation of Rayleigh. Rayleigh correctly explained that the sky is blue because of the phenomenon which is called as Rayleigh scattering, the elastic scattering of photons which lose no energy when they interact with the gas molecules in the atmosphere of the Earth. That's what I meant by elastic scattering. That means a photon interacts with the gas molecule, and the gas molecule goes as a gas molecule, the photon goes as a photon. There is no change. Only some energy would be exchanged between these two. Okay, when Raman was sailing back to India in 1921, he had with him a miniature spectroscope, a prism, and a diffraction grating. I don't know how many of you have heard of a grating. A grating is a very small device which has got something like 20,000 lines per inch. 20,000 lines per inch. Because of that, when the small wavelength light is incident on that, the light gets diffracted. So in all physics students will know that in the lab you either are given a grating or you are given a prism to resolve the incoming, whatever is the incident light. If you want to find out the wavelength of the light or whatever it is, spectroscopy experiments, whatever you do, they deal with either a prism or a grating. So he had a grating also with him, diffraction grating with him, and he used these to study sky and the sky and the sea, and concluded the sea was scattering light. Raman reported his findings in a letter to the journal, which is a famous journal called Nature. Back in Calcutta, in his laboratory, Raman and his students started an exhaustive research program into the light scattering by not only solids, liquids, gases, all of them. So he did a whole gamut of experiments. That's why he had a lot of publications, about 450 in all, in his lifetime. Raman's brother persuaded him to write the civil services exams, as I mentioned to you, as the government jobs were highly paid and the large family was in dire straits financially. Raman worked as a civil servant at the Indian Finance Department in Calcutta, today you call it as Kolkata, and rose quickly to a senior position. He was the first to investigate the harmonic nature of the sound of the Indian percussion instruments, the mridangam and the tabla. His initial interests were in the bowed string instruments. His father was playing the violin, so he got interested in how the vibrations are capable of producing that kind of a music, and how playing the violin is, I think, much more difficult than playing the veena, because veena has got positions where you can hold and you can pluck and you can get the different sounds, but veena is continuous, so it is much more difficult for you to play the violin. So he was interested in the bowed and instruments, string instruments, which are plucked or bowed instruments, and his initial papers were all on the violin and the other instruments. But one of the most beautiful things which he did was regarding the mridangam and the tabla, the drums. Raman realized and proved that the Western drums produce noise and the Indian drums produce music. It's a statement which is substantiated, and he showed by very simple experiment. I will show you some pictures about that. He investigated the propagation of sound in acoustics of buildings. Acoustics of buildings means that, you know, this building has got, if it is echoing, then the acoustics is not good. So normally in a theater and other places, you have to see that you do proper construction of the building. It's a whole subject in itself. Acoustics of buildings is a art. I mean, to make the sound uniformly available. Now, whispering gallery is again a very beautiful contraption. In the St. Peter's Cathedral, wherever you talk, even if you are whispering somewhere, even if the other person is very far away, this whisper will carry to him. That's called a whispering gallery. So Raman was interested in the investigation of how sound propagates here. He investigated the propagation of sound in acoustics of buildings. So whispering gallery is a gallery or dome with acoustic properties such that a faint sound may be heard around in its entire circumference. This is just showing you what happens in a whispering gallery. Red and blue are two different colors to distinguish something. So snapshot of an acoustic whispering gallery mode calculated the frequency of 69 Hz in an enclosed cylinder of air of the same diameter, 33.7 meters, as the whispering gallery in St. Paul's Cathedral. Red and blue represent higher and lower pressures of the compressed air. Sound is actually propagated mainly because of compression of air. So regarding the kind of problem studied by Raman, Ram Seshan, one of his students, said, "It is remarkable that every one of them is connected with his direct experiences, thus arousing his curiosity. He has heard his father play the violin. He worked with the sonometer. Sonometer is one of the instruments which you use even today in the laboratories in physics experiments. And the Milde's experiment. Milde's experiment is a rod which you have to rub, and then you can see the striations inside a tube and all that. It's an instrument which is used for determining the frequencies of substances. He worked with the sonometer, and he did Milde's experiment in college. So follow his papers on bowed string, the strut string, the maintenance of vibrations, resonance, aerial waves generally by impact, the sound of splashes, the singing of flames, music from heated metals, and many others. So that is what is remarkable. He's looked at everything and wanted to study what is the physics behind it. So Raman also worked on the acoustics of musical instruments. He worked out the theory of transverse vibrations of bowed strings on the basis of superposition of velocities. He was also the first in superposition of waves is different from superposition of velocities. So he did superposition of waves. He also did superposition of velocities. He was also the first to investigate the harmonic nature of the sound of the Indian drums, such as the tabla and the mridangam. In contrast, the Western drum is unmusical and just a noise producer. Now, how did he prove this? Raman also worked on the acoustics of, this is the same repetition is here, whispering gallery, it's a repetition. So, Raman was encouraged by Asutosh Mukherjee to work at the Indian Association. IASCS is in a state of hibernation when he went in there. In 1917, he was sought by the University of Calcutta, which offered him the Pallitt Chair. At the age of 28, the chair meant a substantial cut in his pay. Raman paid more importance to science and considered what more than the money which he was going to get out of it. So it gave him the opportunity to devote all his time to his first love, which was scientific research. Although the Pallitt professorship was a full-time research position, Raman, due to his passion to communicate, gave lecture courses to students who were willing to take physics and do research. Now this is the proof that the Western drum makes noise, whereas the Indian drums produce music. So C.V. Raman, this is a paper which he has published, and these are from his paper on Indian musical drums. I will not go into the detail. These are known as normal modes of uniform membrane. See, it's a stretched membrane. You know that to put it simply, what he did was to realize that the Western drum is a single membrane of uniform thickness, stretched. It's a stretched membrane. So it produces only one frequency. So when you beat a drum, it will produce one frequency. So you must have seen the jazz player there. I do not know, at least some of my elders here who might have heard of one of the occasions when Palani Subramanya Pillai challenged a jazz player. This happened, I think, in 1960s or so. A jazz player was, you know, if you look at the jazz player, that guy will be sweating out his whole life. I mean, he has something to hit here, he has something to hit there, he has to use the foot. And my God, the guy looks as though he has to do all that to produce that kind of music out of what he calls as music out of it. And by the time he is finished with that, he is physically exhausted, and you can see him sweating and perspiring. So apparently, our Palani Subramanya Pillai, he said, it seems, he challenged one of the jazz players and said, whatever pattern which you produce on your drums, I'll produce it on the mridangam. Come on, let's have a display. Let the public decide who is the winner. So it was a contest which had taken place in one of the halls, maybe Music Academy, I don't know where, but it was a contest in which the whole crowd, I mean, whoever was assembled there, thumbs up for the mridangam player, and the jazz player was defeated completely, because he could, whatever he produced, this gentleman, without any sweat, with all that, you know, you should see the play, Umayalpuram Raman. If you see him play mridangam, you can see what it is. So why is it that this happens? This happens mainly because the Indians realized the drum which you see, if you have looked closely, the left side and the right side are different membranes. They are not a single membrane. On the right side of the mridangam, for instance, there is a black central part. Unstable. So when you have it, so you have a different membranes, right? So the mridangam has got two different patterns on. There are four different thicknesses which you can see. If you have played it on the left side, it produces one kind of a sound. There are two sounds which come from the left side. There are two sounds which come from the right side. And the sound which is the most musical is the one which comes from that black central part. And in fact, to get that sound, you must be trained. So I was so fascinated with the drums that I spent almost 2 years trying to learn up to Adital in the mridangam. And then I said, it's too much sweat for me. I'm not going to be a player in it any time on the screen. But I understood the physics of it. So what Raman did was something fantastic. What he did was, he took the Western drum, struck it, because the vibrations will be there for some time, and threw sawdust on top of that. He did the same thing with the Indian drums. So he took the mridangam, he took the tabla, he struck them and threw the sawdust. And what he saw is what is well known for people in physics as Lissajous figures. And I have to explain that, but let me not explain that because that's a physics experiment. What they found was patterns. There were patterns which appeared when the drum was struck, when a mridangam or a tabla was struck, and then they strewed the sawdust. It showed beautiful patterns which were not there when they were doing the same thing with the Western drum. The reason for that is physics-wise, you will see that there are different frequencies which are here. You get not only the fundamental frequency, there is only one frequency in the Western drum. You do not get more than one frequency there. But in the Indian drums, you get the single frequency and its harmonics. Harmonics means if you have a particular length, there could be one wavelength in it, there could be two wavelengths, there could be three wavelengths, there could be four. The distance is the same, but you can have many wavelengths. That means they are called harmonics. So Indian instruments, the way in which they are made, they produce the harmonics. And harmonics are the ones which are musical. They contribute to your enjoyment of music. A single frequency, if supposing you have a tuning fork, for those who do the experiment, and you strike it, it is 256 hertz. I mean 256 cycles per second. It will only make a buzzing sound. All these bulbs will produce the 60 cycle hum. I don't know how many of you have realized this, because when the tube light is on, if everything else is quiet, you will be able to hear a hum. That's a 60 cycle hum, which is an audio frequency which is emitted there. So Raman's interest was initially on musical instruments, and later on, So அது ஒர்க் பண்ணுமா அது ஸ்லைடு அதில் போட்டு லைவ் போதா சரி So I think what I will do is my 5:15 is approaching now. So I think I will conclude now because the slides which I have prepared to show you about Raman, the rest of it which I wanted to show you, I don't think I will be able to show because the connection is gone and it fell down. I don't think I did anything wrong, but I'm sorry that I was. You cannot be standing like that, you know. You moved my finger and maybe hands and maybe that's how it happened. So, huh?
It's got its own harmonics.
So now what I will do is, so Raman had a complete life. I mean, he lived up to 80 years and he did many things and there were quite a few students of his. One of the most famous students of his is G.N. Ramachandran. I have a list of the names of the people who were his students. G.N. Ramachandran was one of his students. Ramseshan was one of his students. And Panchanathan was one of the students. So I have the names of all the PhD students. There were 5 or 6 PhD students. And he had a few others. Like K.S. Krishnan was never a student of his, but a collaborator of his. And there are controversies also about which are associated with Raman. Good. Thank you. Thank you. So these are the patterns. You can see the beautiful patterns which appear here. So these are the patterns. And then the Raman effect itself. What is Raman effect? It's called an optical analog of Compton scattering. Now what is Compton scattering? Now I think I will not, I will skip all this because my time is up. I think the documentary will take about half an hour's time. It's, huh? Yeah. So I will just mention what this Compton scattering is about. Compton scattering is that a photon, which is a wave which you see here, a photon So I don't know whether you can see. This is a photon. There's an electron which is here. The photon comes and hits the electron. Then the electron recoils. The electron gets in one direction. The photon goes away. So this is simple experiment. A photon is incident on an electron, and the electron is stationary initially. So when the photon comes and hits the electron will gain some energy, and therefore it will move in one direction. The photon will move in another direction. Simple laws of conservation of momentum and conservation of energy is all that is required, and with that you will be able to get an equation which tells you about the changed frequency of the photon. If the wavelength of the photon initially is lambda, the photon which is going out will have a different wavelength, and wavelength is related to frequency, and E is equal to h nu, therefore frequency is related to energy, and so on. So from energy momentum conservation laws, very simple calculations will tell you what exactly would be the wavelength of the photon which is going away from here. So the experiment is very simple. A photon of wavelength lambda is incident on an electron at rest. A new photon of wavelength lambda prime emerges at an angle theta. The electron recoils and an angle dependent amount of incident energy is carried away by it. So there is something called Compton getting effect. I am not going to go into that. Now basically Raman effect, when Raman looked at this, he said if this is happening in the case of X-rays, what was used by the photon is in the X-ray region. So Compton received the Nobel Prize in 1927, and he was using X-rays or photons or X-rays as the incident particles. So if it was happening at that particular frequency, why not this happen at other frequencies also? Because the frequencies are continuous. An electromagnetic spectrum can go from infrared to ultraviolet. It's a two ends of the spectrum. Visible part of it is there. So if something is happening only in this particular region, X-ray region, why would it not happen in the visible region? So that's exactly the idea which he had. It's a very simple idea. You change the wavelength and go into the visible region. Will the visible region, in the visible region, will there be a shift in the wavelength? So he predicted that it should be there, because it doesn't matter whether we are going to be in the infrared region or the ultraviolet region or the visible region. It should be the same. So this idea that there must be the commonness of the wave property of light was what made him do the Raman spectrum and then predict that there will be a shift in the wavelengths of the light which is incident on a prism. So his experiments were simple experiments which he did, and he was able to prove and establish this. He was so confident about the whole idea. As I told you, what happens here and what happens there would happen also in this region. That's about all that he said. So it is as simple as that. To put it in simple words, it is like that. But that thought should come to a person, and he then has to prove it. He has to use the experiment, he has to have an apparatus, he has to make the people do the work. Then he used solids, gases, liquids, everything, and in all of them he showed that this was there, and it became famous as the Raman effect. So Raman effect was established, and 2 months before the Nobel committee was to meet, Raman booked his passage for himself and for Lokasundari, his wife, to go to Sweden to receive the Nobel Prize. That was again the amount of confidence which he had in the work which he had done. So not only that, even after he received the Nobel Prize, he would not bow to anybody. I mean, you have seen, I mentioned to you about how he treated Nehru or Prime Minister or whoever it is. For him, science was important more than anything else. And when he got all the money from the foundation, what did he say? He said, he got also the position which was given to him. There were a lot of problems between him and other physicists, like there was a Born, Max Born was a physicist with whom he had a controversy. He had a controversy with quite a few other people also. I don't want to go into those stories, but they are interesting stories, but out of which Raman emerges as a person who had a supreme confidence and supreme ego. So it was his ego which was responsible for some of his problems which he had. He isolated himself from the others, but he was still directing and doing research. And with all the money which was given to him, he told the people, he got a position in the Indian Institute of Science in Bangalore. So that he was offered the professorship, and he set up the Department of Physics of the Indian Institute of Science is due to Sir C.V. Raman. There was no physics at that time. Indian Institute of Science was built by Mahendralal Sarkar, and there was no, Tata. The Tatas built the Indian Institute of Science, and Tatas did not think of physics at that time. But when the Tatas came to know that Raman had won the Nobel Prize and he was interested in coming back, they were willing to offer him a chair and a professorship and a department to be set up by him. And today, Indian Institute of Science is the showpiece for the country, and physics department is one of the good departments in the Indian Institute of Science. So Raman's fame went sky high, so he could do whatever he wanted, and I think he did a very good job. He had guided half a dozen people for their PhDs, and one of them was G.N. Ramachandran. And G.N. Ramachandran was almost a person who won the Nobel Prize. He is also from these parts. And G.N. Ramachandran came up with the idea of a helical structure for crystallography. It was the double helix which won the Nobel Prize. He suggested a triple helix. So it was missed by a whisker. Actually, there are many who feel that the Nobel Committee is not always right, and they should have even considered G.N. Ramachandran as one of the members for getting that Nobel. So in any case, the story of Raman is a success story of a person who, with minimum amount of equipment, was able to do work which was international in nature. His publications were all in international journals, and he was recognized by the biggest authorities. He had good friends in all the people who were doing quantum mechanics at that time, and there is a quantum mechanical interpretation which was also, somebody asked him, is there a quantum mechanical interpretation? And there is a quantum mechanical interpretation for the Raman effect also. So he was a complete physicist and a role model for many to follow, but also a person from whom you have to learn not to have certain qualities. So Raman is a complete human being with his own small failings. So that's the picture which I wanted to present to you. For those who are interested, G. Venkataraman's book is available for, and anyone, if you want to ask me anything, you can ask me a little later. Now I will conclude by showing you a documentary which was made by, I'll just 1 second here. This is the person who made the documentary. Actually, this was made for Ramanujan, but he is the person who made 65 documentaries in all. And this gentleman, Nandan Kudyadi, is running an organization in Pune. He owns a place, and he is the director and a producer for several documentaries. And he made this documentary on Raman long time ago. In fact, long before I came to know this person, I was impressed with the documentary which he had made on Raman, and that's the documentary which you are going to see now. So adula potrala illa pottuma. Hello. Huh? Okay. Okay.
This will be for the audience. That will be for the live webcast.
Journey into light. This is not the one. This is not the one. This is not the one. ஒரு டேபிள் அந்த சின்ன டேபிள் வைக்கலாம் சார், அந்த டேபிள் வைக்கலாம் சார். இது ஸ்லோப்பில் வச்சு விழறதுப்பா. அது அந்த டேபிள் இருக்கேப்பா, அது கொஞ்சம் இங்கே வைப்பா ப்ளீஸ். இது அன்ஸ்டேபிளாக இருக்குது. எனக்கு இது முன்னாடியே பண்ணியிருந்தா அது கீழே விழுந்துருக்கா. அப்படியா? ஆடியோ ஆடியோ ஒன்று இந்த மைக்ரோஃபோன் வச்சு அது இது அங்கே வைக்க முடியாது, அது இங்கே வைக்க முடியாது.
To bring home the Nobel Prize in the scientific field. I thought I would build true science in our country. All we have now is a legion of camp followers of the West. There can be no salvation, no real advance. So we just real. His name, the Raman effect. Why then, in the twilight of his life, does he look back not with pride and satisfaction, but with pain? He was a man of strong convictions and innovative ideas, many of which are as relevant to Indian science today as they were at the turn of the century. This film is not just about the life of a famous man now no longer with us, but also a tribute to his genius. This is a film on the legacy of Sir C.V. Raman. The young Raman was curious by nature. He wanted to know more about everything that he saw and heard. For the rest of his life, this curiosity, combined with an inherent love for nature, drove him to study her many facets. Even at the age of 82, he was exploring new vistas as actively as he did as a child. For him, science had always been the key to understanding the workings of the world around him. Fascinating, he mastered such classics as Ganot's physics. There is a story that late one night, despite high fever, he refused to sleep till his father, a science lecturer, fetched a Leyden jar from his college and showed him how it worked. See, a large amount of charge is accumulated at the bottom. You connect this to the electrode, it gets discharged.
அப்படியா? There's a spark.
Raman was born near Tiruchirappalli in Tamil Nadu in 1888. From there the family moved to the coastal town of Visakhapatnam when he was 4 years old. The sun, the sea, nature in all its primordial beauty here must have first stirred the young boy. He began to ask questions. His father encouraged his curiosity. As Raman's thirst for knowledge grew, he was spurred to take science up seriously in later years.
What are you doing now, young man?
Sir, I'm trying to work out a new method of measuring the surface tension of liquids.
New method? Why?
Because by the usual method, either the drop is not steady or it falls down in the middle of the observation. So I thought if I could photograph the drop profile, it would be easier to calculate the surface tension.
Sounds ingenious. Carry on.
Oh, sir. Professor Jones, sir. One moment, please.
Yes?
Some time ago, I'd given you a paper of mine for comments.
A paper?
Yes, on unsymmetrical diffraction bands when the incident light is oblique.
Really? Ah, yes. Perhaps you did. Well, it is nothing much to go by. Nothing at all. Carry on with your work.
Raman was not discouraged by Professor Jones's lack of interest. Instead, he took the initiative and sent his paper to one of the most respected scientific journals, the Philosophical Magazine in London. And it is to his credit that he had enough confidence in his first independent experiment to be able to send his findings to such a reputed magazine. For then, as now, education was a means towards a degree. Students were not encouraged to think independently or to use their initiative. Colleges in India did not have a tradition of research. Which of course brings us to a very fundamental question.
What is research? It is only seeking after knowledge. Knowledge is not dead and enshrined in books, but living, growing. It is the attempt to discover new facts and new relationships between known facts. A university is not a university if this is not understood. You must be one of the seekers, else you'll be left behind.
Way back in 1907, a handful of Indians were still struggling to create a niche for themselves in areas dominated by the British. There was no scope for a scientific career, as there is now in post-independent India. So Raman decided to do the next best thing, join the government. Topping the entrance examination to the Financial Civil Service, he was appointed Assistant Accountant General, the youngest ever to be so appointed. This was a period of great change in his life, for he also happened to meet his future bride, Lokasundari. The couple were married, and on Raman's posting, moved to the bustling capital of the Raj, Calcutta. But Raman had not lost his interest in research, and one day, at 210 Bull Bazaar Street, he stumbled upon the Indian Association for the Cultivation
I would like
of
to meet
Science.
the person in charge.
Ashwin, come in.
What did you say your name was? I will write it down.
C. Venkatraman. I'm a government servant. The Assistant Accountant General, in fact. But I'm interested in continuing to do my research in my spare time. Original investigation in optics and acoustics.
Well, come with me. You see, we do have a laboratory.
But it's so decrepit. You know why? Because in the 30 years since it was built, no one ever came to me and said he wanted to do research. The epitome of science in our country. This place was built with many hopes by my uncle, Mahendralal Sirkar, a staunch nationalist. He believed that science can change people's way of thinking. He started lectures. They became very popular, but no one was interested in anything beyond that. I would like to do my research here. You would? But only after office hours. I can't let the timings clash. Of course. Ashu Babu will be here to help you. But you will want something. An honorarium? Our funds are low, and I'm afraid I can't afford to pay you very much. You needn't worry. This is all that I need. I'll start tomorrow evening. Thank you, Mr. Raman. Thank you. All these years we have been waiting for someone like you.
The most notable piece of work he did was on the study of the vibrations of the Indian drums. The mridangam and tabla are rather unique instruments in that they are the only two drums in the entire world which can produce a group of harmonic overtones. Raman discovered that these drums give harmonic overtones by the particular loading to which these drums are subjected. For example, the fundamental mode of vibration comes when the drum head vibrates as a whole, and the second harmonic comes when the drum head vibrates in two halves, the central line remaining at rest all the time. And the third harmonic comes from this mode of vibration with one nodal circle or two nodal diameters like this one. These two modes can combine to produce a variety of modes of vibration.
You see what I mean? Such wonderful tones. Of all the musical instruments, the veena comes closest to resembling the human voice.
Really? I've been seriously playing the veena for so many years, and I never realized it.
The strange fact is, there is a law in Western science which states that certain overtones just cannot be produced by any musical instruments. But the veena violates it. You know why? All because of this curved bridge, whereas Western instruments have flat bridges. How much our ancients knew about acoustics. Do you know something?
What?
The Germans have asked me for an article.
Uh-huh. That's good.
Yes. It's just not enough to do research anymore. You must publish the results immediately. So emanated the first research papers from the IACS, 30 years after it had come into existence. During those early years, Raman worked for the most part alone. Even so, the publications poured out. In fact, so fired was Ashu Babu by Raman's enthusiasm that even he wrote a paper for the Proceedings of the Royal Society. And Ashu Babu had never even been to college. Raman's fame began to spread. Not only did he become a source of inspiration to young research scholars like Venkateshwaran, Ganeshan, and of course, K.S. Krishnan, but Sir Ashutosh Mukherjee, the Vice-Chancellor of Calcutta University, offered him the Pallet Chair of Physics at the University College of Science. He accepted this post gladly, even though it meant receiving only half the salary that he earned as the Assistant Accountant General. Why is the sea blue? Lord Raleigh had said, it is simply the blue of the sky seen by reflection. But looking at the deep color of the Mediterranean Sea on my way to England in 1921, I began to doubt him. So I decided to use a simple mode of observation to view the surface of the water through a Nichols prism at approximately the polarizing angle with the surface of the sea. The Nichols prism quenched the reflection of the sky, and to my surprise, the blue of the sea became even deeper. Thus, it was very clear the color of the sea is a distinct phenomenon in itself. But what diffracts the light and makes its passage through water visible? Could the diffracting particles be, at least in part, the molecules of the water themselves?
Raman found out that the sea is blue chiefly because the molecules of water scatter sunlight. Inadvertently, a whole new area of research had opened up. It triggered off an exciting series of experiments, which after 7 arduous years culminated in the discovery of the Raman effect. On that historic day, March the 16th, 1928, Raman gave his first public lecture in this very hall to propound his theory. It was called A New Radiation.
I propose this evening to speak to you on a new kind of radiation, or light emission from atoms and molecules. To make the significance of the discovery clear, I propose to place before you the history of the investigations made at Calcutta which led up to it. In 1923, it was K.R. Ramanathan who noticed the strange phenomenon while he was studying the scattering of light in liquids.
Professor Raman, this green filter, it's complementary to the violet, so it cuts off all the violet color passing through. But when I place it here, in the path of the scattered light, the result is not the same. There's a track of light visible.
A track of light, in spite of a complementary filter. Why?
I don't know. I suppose it's a weak fluorescence due to impurities still inside the liquid. I'll have to purify it even further.
What do you think, Krishnan?
I don't know. I've investigated more than about 60 liquids. Among them, not only water, but some alcohols too show the fluorescence quite markedly. But what puzzles me is, whereas fluorescence is generally unpolarized, the scattered light here is polarized.
I'm beginning to wonder, is it fluorescence at all? Because if it's not fluorescence, then it should be scattering. Because Rayleigh scattering can be polarized, and it would be strong. Whereas the track that we have over here is so very feeble. Could it mean, is it not possible that it's not fluorescence at all, but altogether something new, something different?
Not fluorescence, not Rayleigh scattering. You mean a new kind of radiation?
Sir, I've just studied the visible radiation excited by ultraviolet light in pure dry glycerin. It's strongly polarized.
What?
And the track is a brilliant green instead of the usual blue.
Green? A change in wavelength and polarized? This definitely cannot be fluorescence. This is something new. Boys, remember, I'd always said there must be an optical analog to the Compton effect. Is this it?
You mean when X-rays are scattered by atoms, there's a change in frequency?
Exactly. Just imagine, if there's a change in wavelength with the scattering of X-rays, I think the same effect can take place with the scattering of visible light. But how do we prove it? The track that we have is too feeble. We should try and make it stronger. Probably we'll have to use a larger lens and complementary filters. Krishnan, I think you should follow it up.
I, sir?
Yes. I think I need somebody who can use the sunlight throughout the day. I've got my classes and Venkateshwaran's busy working, so he can only come in part-time. Besides, you stayed away from experimental work for too long. Not at all healthy for a scientist, huh? This is marvelous news. Just wonderful. You understand what I mean? The first step taken in the research was to find whether the effect is shown by all liquids. The method of investigation was to use a powerful beam of sunlight from a heliostat concentrated by a 7-inch telescope objective, combined with a short focus lens. This was passed through a blue-violet filter and then through the liquid under examination, contained in an evacuated bulb and purified by repeated distillation in vacuum.
It's true of visible light, sir. It's true of visible light. There's still a track in spite of the complementary filter, sir. It's polarized. And there's a change in wavelength.
But links are still missing. How do I show that there is a change in energy or a change in frequency? Frequency, color. The spectrum, of course. The spectral lines will indicate any change in frequency. Asha Babu, arrange for the spectroscope. Quickly, quickly! Where's Krishna?
Not come today, sir. Religious ceremony in his house. It's ready, sahab, but the sun is setting. The light will not be strong enough.
Oh, dash it all. First thing tomorrow morning, huh? Next morning I could see the spectral lines, but they were not clear. It occurred to me to change the light source, to use a monochromatic light. Asha Babu, get me the mercury arc lamp. It's so clear, Krishnan, so very clear. In the blue-green region, there are 2 sharp lines instead of 1. What? Yes. Between the incident line and the new line, there's a distinct dark space. The new line must be of a different frequency. It shows a change of energy.
The new line that Raman discovered indicates the amount of energy lost or gained by a photon of light when it interacts with an atom of matter. This in turn tells us a great deal about the atomic and molecular structure of that substance. It was a momentous discovery that paved the way for new research in almost all branches of science. C.V. Raman was awarded the Nobel Prize for Physics in 1930. It was a moment of great significance, for not only was it a tribute to the man, it also officially put a country struggling for an identity on the scientific map of the world.
Today, it is being used to solve important problems, not only in one branch of science like physics, but in many branches of science, almost all branches of science, chemistry, biology, material science, earth sciences, and so on. Even on application sites, it is always a part of analytical technique which is used for high technology. For example, in microelectronics, space, nuclear fusion, optoelectronics, you name it.
The man was once the center of scientific activity in India. He is now a recluse. Perhaps because success inevitably breeds envy. When Raman was appointed to the Palit chair, the impression began to be created that he was a has-been physicist, working on highly dated problems, while a new wave of physics was sweeping the rest of the scientific world. Raman's own nature did not help. His ego had alienated many people. In the years following the Nobel Prize, the resentment against him grew more vocal. It was said that Raman did not understand the significance of his own discovery, that it wasn't even his, that it was Krishna's.
It depends upon the point of view that you take. For example,
If we ask ourselves, who was the first person who observed the Raman effect? There is no doubt that the first visual observation through a direct vision spectroscope was made by Raman himself. The question is, who took the first recorded Raman spectrum? It was K.S. Krishnan. Raman got the idea that sunlight must be replaced by a mercury arc, and Ashu Babu, Raman's famous assistant, and K.S. Krishnan adjust the spectrograph, and K.S. Krishnan developed the film. And so we could say he recorded the first spectrum. But that is not the real point. One should always ask, who got the idea? Who was behind this thing?
In 1933, Raman came to Bangalore. He'd been offered the directorship of the Indian Institute of Science. The institute had never had an Indian director. They had always been British. The institute had also never had a physics department. Raman set about creating one.
Oh, there's so much that can be done. You know something? Max Born is coming.
Sir, have you heard from him?
Yes, I received his letter this morning. He's accepted the readership I offered him. Just wait and see, my friend. Things will begin to change for India. No more will our youth have to go abroad to get initiated into research. But as it is, I don't like the practice. The environment over there is so very different, and the conditions here makes them useless here. You know what I feel? If great men like Max Born and Schrödinger were leaving Nazi Germany, they can be provided with a home here, then perhaps there can be started off a real scientific movement in the country.
The renowned physicist Max Born did come to India, and soon Raman strove to make his position permanent. But all Raman's reforms were too sudden. They ultimately led to a major controversy.
The problem between C.V. Raman and the council leading to Raman's resignation has many facets. I shall briefly mention 4 of them. First, Raman was the first Indian director to be appointed. 3 Britishers had preceded him, and the British faculty members were rather reluctant to work on an Indian director, as evidenced by Max Born's letter to Rutherford. Second, Raman had some attitudinal problems. He was an extrovert with a sharp tongue and oftentimes overbearing. He lacked administrative tact, which is so essential for a director. The third aspect, there was no physics department before Raman came. He created it and he equipped it. There were tensions and charges that Raman was building the physics department at the cost of the other departments. The Irwin Committee was not all that objective. Its members were prejudiced against Raman, and Raman ultimately tendered his resignation from the post of directorship and continued to work as the head of the Department of Physics.
Having no alternative, Raman decided to stay on. He continued to do research of a high quality in optics, crystal physics, and ultrasonics, in which the Raman-Nath theory is an outstanding piece of work. But the controversy had left its scars. The problems that Raman faced in his attempts to upgrade the institute were to him representative of larger issues at stake. These included the need to recognize the importance of fundamental science, to manufacture equipment indigenously, and to make universities centers of research.
2 years before my retirement from the Indian Institute of Science, I started building my own center. I called it the Raman Research Institute. There was no water, no electricity when I first started. But that didn't make a difference. At least I could do my highly personal research work without any interference. You know what I mean? Like the poet and the painter, the scientist too is motivated by an inner creative urge. Only earlier, I felt I had to prove my findings to others. They, if I have seen and understood, I am satisfied.
Although certain aspects of Raman's personality and work have been criticized, there is no doubt that he was instrumental in laying the foundations of the entire edifice of Indian science. Apart from physics, he was equally interested in the growth of the other fields. These fields were not to be developed in isolation, but in relation to each other. So he created a national forum, the Indian Academy of Sciences. He also wanted science to reach the masses. His popular lectures were always comprehensible and tinged with humor.
What we lack is perhaps courage, driving force. We need a spirit of victory, a spirit which will recognize that we, as inheritors of a proud civilization, are entitled to a rightful place on this planet. If that indomitable spirit were to arise, nothing can hold us from achieving our rightful destiny.
Raman died on November the 21st, 1970, here in Bangalore. He was 82. His death marked the passing of an era in Indian science. A unique memorial marks the spot of his cremation. It is, as he himself would have wished it, this solitary tree.
So I hope you have enjoyed the show. Thank you very much. I think we are running out of time. So if you have anything to ask, I am going to be down, available for you to ask. Thank you.
I'd like to thank Dr. Srinivasa Rao for accepting our invitation. He actually offered it a couple of years back or so, year or so back. Then he went to the US and we wanted him, and so I'm glad by coincidence actually it happened that he happened to give this talk in November. It wasn't planned, but it worked out very well. So we also got a practical demonstration of the effects of an inclined plane on a reclined laptop, which was unexpected. So Raman went to, started at Thiruvannaikaval and went to Sweden to get his Nobel Prize from the Raja of Sweden. We got something pretty close, sir. We have the Raja of Tanjavur in the audience, so I would request him to come to the podium to honor him with a little token of our appreciation. From Thiruvannaikaval to Tanjavur, we come a full circle, I suppose. And
it's a very enriching experience. I actually, on the invitation of Professor Swaminathan, I had this wonderful opportunity. I thank sir for enriching us and for the audience. Thank you, sir.
If any of you are interested, the whole book of G. Venkatraman, Journey into Light, is available here in a CD. So if you want, I can make a copy and give it to you. Thank you.
Okay, thank you. We are almost out of time. Normally we would take a few questions, but thanks, because of the delayed start and a little technical difficulties, We thank the TVA staff for their help in the program. Apologize for the delayed start. Next month, our speaker is Dr. Vilanur Ramachandran of the University of California. He will be delivering a lecture on the 28th of December. Once we finalize the program, we will let you know the details. Thank you all for coming. I hope you have entered your name in our register. We can send information of all our programs. And there's also a WhatsApp group and a Facebook group if you want to follow our programs. Thank you very much.